I'm Marco. I'm an idiot. I sometimes try to be smart. If you remove the context, I'm just an idiot. That's what's on the website. I'm mostly doing open source, and I waste my time in trying to maintain software that should not be maintained. If you see this avatar, you know you're going to have a deep review of your code. I work for a company called Rove. We're consultants. What does a consultant do? I take your money, and I use it to go to conferences. So far, it worked amazingly. This is an interesting talk, and Rasmus left me a big pair of shoes to fill here, because I'm kind of like, I started doing PHP after it kind of lost control and went into being a proper language, you could say. And I started doing PHP around 2001, 2002. And I had my first, proper client work. And you have your client. The tool is what it is. Still a cool tool, but it is what it is. And you got customers. Maybe not the best customers, but they're willing to pay. And you're going to go on with the project. So just a warning here. You're going to see a lot of code that you've already seen and you hope you won't see again. But I think people that have been working with PHP for a longer time already have seen most of what is in this talk. Of course, we start every one of our scripts with our functions, php.inc. It must be .inc so you can load it with a web server, right? And you can see it in clear text, maybe with the database password and everything. Of course, we loop over everything that comes from the request. We don't care how, and we put it in a global variable. And that's how you used to work, right? This is obvious. This is required. And again, it used to be a very simple language intended for very simple things. And we started doing more complicated things. Now, if you want to have fun, just go through this code and figure out how many security issues there are. But of course, we use globals, so we don't need to actually check where parameters come from. So first of all, we introduce our security layer. And then we run some queries and we select products. Of course, this also comes from the request. We trust our users to not misuse the system. And we just put an advertisement on it. Just don't use double quotes in your username and stuff like that. And then I forgot or die my SQL error, big mistake. And then you do data validation. So we are verifying that the inserted credit card is 16 characters long. I had systems that saved credit cards, I don't remember where they were, and you can, chase me and try to get out of me where those systems are, but I will not tell you. And of course, the success now is true. This success is true. Success is assured. And obviously, save the credit card. Save the credit card. It's important that all the information is saved. Well, and then, okay, thank you for your purchase. And we used to code like this. And then I'm making it simple because I'm assuming that we split the script in two. So it's not like that. Usually it's like HTML mixed with everything. So I made two separate files. So I'm already assuming somebody came in here and decided, okay, let's have some kind of order. Well, first of all, if there is no certainty of success, well, then we're going to display an error. Success can also not exist. And exiting. We did this a lot. And well, fair enough. This is how we used to code. So far, so good. And security is what it is. It gets the job done, and the idea is that projects were much easier. The extent of a complicated PHP script was create a counter at the bottom of the web page that says how many users visited that website. And now you can go back on your old website and look at how depressing that counter looks like now. 1,000 visits after 10 years or something like that, right? And the idea is that it gets the job done, even though it's probably not the best tool. But effectively, we got better over the years, and expectations from professional programming are different now. And at the time, we put everything in globals. There was a nice talk right now about how these decisions were taken, and it kind of got the job done, and so far so good. But we're doing that. We're having no security. What is interesting to me is that we started doing this. We started realizing that there's some common shared amount of things in our system that are always reused, and they're not necessarily part of the execution of our current script. They're kind of transversal. So I call these helpers. So the helper is something that you import. It solves a problem that is not your direct problem, but something on the side. And we need to solve that problem 100 times and repeat and repeat and repeat. So I want you to focus on this concept of helpers, but effectively we improved over the years. And the customers used to do this thing where you said we are going to do a redesign. I think there's people here that still work in companies where every 5 years you do a redesign, right? Anyone doing that? Couple of web agencies, yeah. So the idea is that at this point the client will pay, and they will pay for a full rewrite. And that's not really avoidable. Because you inherit one of these projects, there's no SVN, CVS, Git was not a thing. You have no idea what's going on. Here's the password credentials for the server. Just figure it out. And you download the code and you hope to understand something. So it's always landing in a rewrite scenario. But the good news is that maybe the project was small. I had some projects that were really small, really easy to translate, and some projects that were gigantic. Years and years of work done in a very chaotic way and very, very hard to track. So a few years later, what happens is the first frameworks. So we're talking, well, I know there's Agave framework and other ancient things that nobody heard of, but the idea is that we start having frameworks around 2005, 2006, something like that, and the framework authors know what's best for you. They have an idea of what's going on. It's not like that. It's just other people trying to figure out the stuff and trying to mash it together and looking at what others are doing and copying. And the good thing that I feel came from this age is that we started seeing this separation of concerns inside our applications. So one of the big things that happened around 2009, 2010, is that every conference you went to, they talked about is MVC. MVC, 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 everything must be MVC. Well, we had this idea of doing MVC in PHP. It doesn't really work out. You have this MVC-ish structure, because you can't really do MVC over HTTP, because everything is stateless. But the nice thing is that we started seeing some separation. We started seeing people putting things in controllers, usually everything. So you start seeing some code that I wouldn't say is super nice, but it kind of makes some sense now. So good things. We started naming things. We have our purchase controller, and the purchase controller, of course, has to extend from the framework. Then, like for maximum coupling. It's like a GPG signature. My code is signed by the framework. And then you start having names for what you're actually doing instead of here's some random if block taking a decision. And then we start doing some actual security. If this is not a coyote, yeah, your framework is not going to be a coyote, but the idea is that we started seeing this function calls, method calls, in the middle of controllers usually, and these method calls were stashed out somewhere else, but we are a bit more aware that there is security and that it has to be considered. We start having form validation. This is when people figured out, oh look, CSRF is a real thing. By the way, CSRF is kind of already dead if you considered the new same-site policy for cookies, but we started solving some problems, and then you do some business logic. Well, this is the actual business logic, so I'm going to assume there's some magic there. But you start getting rid of all these transversal concerns and, like making everything an if-else, and it's kind of messy overall. And instead, you have named concepts. So this is good progress. It was not necessarily nice code. You go ahead and look at one of your old projects from 2009, you're not going to like it, but not even a bit. But we had solved some problems. So, for example, I learned about CSRF from frameworks. I had no idea what CSRF was. I learned about most XSS vulnerabilities and the fact that escaping is contextual because my framework taught me, oh, look, this concept exists. Doesn't mean that I have to solve it through the framework, but if they hadn't published it and I hadn't looked at the docs and figured out, oh, this also exists, I would have no idea that some of these vulnerabilities exist. So assuming you're using framework components to solve your problem, the security problem is hopefully solved. Well, We're still heavily relying on this concept of helpers. And now we're writing helpers, but they're no longer in their function includes, but they are kind of in this thing called the helper registry. Helper registry. Anybody done Zen Framework 1 here? Yeah? You remember the front controller and the bootstrap abstract and all that stuff? It was a nightmare. But here's the thing. So you have your base controller. Your base controller uses magic because PHP magic is awesome. We started doing it everywhere. And then this thing kind of figures out a helper by the name of the method you're calling and calls it, and magic happens. So we're using registries. And registries are not really that much better than globals. It's kind of the same concept. It's just hidden away. And we kind of whitewashed it. Now it's object-oriented programming. It's not object-oriented programming. It just looks like it because we're using objects, but that's it. So, and we still do that, I think. So if anybody recognizes this, don't tell where you saw it, but this is something that people still do. Right? And this is effectively a helper. This code is extremely hard to debug, extremely hard to understand what's going on. Stop doing that. By the way, that's not from 2007. The other problem from this age was that users would put everything in the controller. So now logic is in the controller, and then there's the view. And then when he told you about models, the model was the database record. That is the idea of the model. So we still have the problem of too much coupling with the framework. Now the framework is kind of your go-to solution for looking at every problem, which, we switched. Now we had to build everything ourselves. Now somebody solved the problem for ourselves, for our system. Now we are going to only use that solution. So now we are coupling everything with the framework. And we have this singleton somewhere in the middle of the framework. Everything has to go through that. We start having weird conventions. So this is when you started seeing things like, oh, your class must be placed in this code path and have this name in order for the path of the application to be recognized this way. So depending on where you put which file, it would kind of try and understand how to parse parameters from the request URL. And we use this auto-loading mechanism as kind of a service location system. So we solved some problems. We introduced a massive load of other problems. And if you start doing testing, which is something that became popular at this point in time, it doesn't really look that good anymore. So we did a bunch of framework development, and then we had another evolution, I would say. So around 2011, 2012 is when Symfony 2 and Zen Framework 2 came out. I realize I'm saying Zen Framework a lot. That's because I'm from that community. Yeah. If you have your own framework in mind, you can think of that. But this was kind of where we had one jump from one way of writing these tools to a completely different approach. And if you look at a controller again, now it looks like this. This is what we had before. Now, interestingly, this code is now so big that we don't actually see what's going on because we are now having all this constructor stuff. But the idea is that now we have a clear explicit set of things that we want to use. So we have security checks, we have products list, authentication, notification. We have one constructor to wire things together. So if you take this class out of context from the framework, you still know what's needed to make it run. And it's no longer like this needs to really run inside this application, otherwise it will just not run. And we have statically analyzable code because we started using tools that, how do you say, waste your screen space with red error messages. I think most people are not actually solving errors in their code because they care about the code quality, but because there's the tool telling you that there's a problem here. And it bothers them to have everything red on the sidebar. So this is quite okay. It's an improvement over the previous model. And now we have testable code. And there's no magic here. Okay? There's still a magic box, which is the framework that kind of figures out how to make this class work once you put it in the framework. But we got progress. This is an improvement. And we still got a lot of coupling with the framework, though. We're still extending from this thing, and you still have to follow some conventions. So there's always this risk that any upgrade will also be a rewrite. Now it's smaller. It's a smaller risk. But what we were seeing is that every time we told people, okay, we're completely changing this, it would cause an uproar, and very well, deserved one, because it is not easy to just upgrade stuff. So we have to design ahead and make things in such a way that it is easy to upgrade, but also easy to write code. So at this point, we had the rise of a few patterns that made a lot of sense, maybe still make a lot of sense. So like, for example, dependency injection. I'm still fully behind this. Dependency injection is something that we touted a lot. Like dependency injection, dependency inversion, containers, if you want to use them or not, whatever. But the idea that you can finally make things much more explicit. And this was very much eased by the fact that people started testing their code. I wouldn't say test-driven development, but at least you tested your code. So you realize, oh, something is wrong in how my code works because it's so complicated to test it. We had ORMs coming up. Maybe not necessarily the best solution, but one solution to the problem of concatenating strings containing parameters from userland and having SQL injections everywhere. And then later, I would say 2014, 2015, we started seeing people from the domain-driven development community coming up and telling us about how to write code that is agnostic to external tools and that tries to solve our business problem first, and then that the HTTP stuff is kind of secondary to it. So it's an interesting period. There's like a lot of discussion going on. A lot of things are being changed, replaced, or improved in general. So far so good. This is good improvement, but we're still having very much a lot of silos. We have one community building this way, one community building that other way, and if you mix them together, now every upgrade is a nightmare because you're using all the frameworks all together. And that was the only way to make it work, kind of. So we had another evolution. And this is where I think there was a shift in how we design applications inside frameworks, which is the middleware approach. Well, the middleware approach is something that was pushed by Igor Widler in the past. I don't know if anybody remembers stack HTTP. Still kind of relevant to some point in some frameworks. But effectively, the idea is that you want to remove a lot of complexity and say, your application is just a set of steps. And it's kind of layered. And this is true. If you think about it, your application, regardless if you build it in one way or another, is still a lot of steps. You still have the network cable, the ISO-OSI layers in your network stack, the operating system, some router, some firewall somewhere, some reverse proxy somewhere. You still have all of that. And it makes sense to put it that way also in our applications. So in this case, you see you have an authentication layer in the front, which is responsible for verifying incoming requests. And then you have the actual action at the very end at the core. That's probably our domain logic. But everything in between is kind of like all steps that you can add or remove, and they don't change anything in the actual interaction, which is in this case flying. So if you put this in context, we now improved a bit again. And if you look at it, we have a purchase action as we did before. This is very similar to our controller that we had, but you see there's no inheritance from anything anymore. There's no inheritance from a framework. There's no, well, maybe that is not necessarily good, but there's no interface coming from the outside. You still have your constructor arguments, so you still have clear dependency injection, but you have only one method on this, which is the invoke magic method. So our object is now no longer just a class that collects a bunch of interactions, but it contains only one interaction, and it acts as a function. And the function is take a request, produce a response from that request. And if you look inside here, you're not actually doing anything about authentication and validation and stuff like that. We are getting some form data that we assume, big assumption, possibly a problem, but still a good improvement there. We assume that there's valid data here, and we're going to see how that's done properly. And we just perform the interaction. So I want to get a product, and I want to purchase that product with my current user. And then you split out concerns, and you say, I have a separate problem, which is figuring out who can purchase things. So I'm going to write an only coyotes middleware. And this middleware has this weird signature here, request and callable. This, by the way, is a very old version of middleware. It's just, it still holds true from a concept point of view. You're saying, okay, I'm going to get the user. If the user is not, well, user instance of user, I should really update my stuff. Look at that. Code reviews live, on stage. If the user is not a coyote, I'm going to stop the interaction, produce a response, and nothing is happening. Otherwise, we are executing the code for the next step. So we are going to take this next callable and execute this. So far, so good. And then I'm going to say I have another layer that gives me the current user. So this layer is given a request, gets the current cookie, for example. Could be a cookie, could be a token, you don't really know how you want to deal with it. And then you say, okay, given that cookie, find the user for that cookie. How you do that? It's mostly up to you. Probably stuff you should not write yourself. This is authentication, which is a problem that is already solved by people that are very security aware. And then if that's not a user, then you're going to return a 401. So one is a 403, the other is a 401, and if you have your user, you're going to the next layer. And then you're going to add another layer that says form validation. So this is only if you have valid form data. So you're going to perform validation over the request, and you're going to get invalid and valid. If the request is invalid, then you're going to render an error message, a 422, unprocessable entity in this case. And otherwise, you're going to execute the next action with the valid form data. And when you put it all together, this is what your application looks like. So your application is only for authenticated users that are only coyotes, only with valid form data, and then if that all holds true, then you're going to perform the purchase interaction. And this is something that is very easy to understand. You look at one configuration, you have exactly an idea of what's going on there. I wouldn't say it's actually necessarily improving over having one big if-else, if-else, if-else scenario, but at least these common scenarios of taking a decision and stopping an interaction can be taken in one location and tested in one location. So in an imaginary language that I like, you say my application is something that takes a response, pipes it through only authenticated, pipes it through only coyotes, only with valid form data and some form that you configure, and then you perform the purchase here. This is possible through some newer kind of PSRs. I think they're called Phil Sturgeon recommendations. Oh, no, nobody got that? I don't care what you call them, but they are, I think, good libraries, interfaces, published by a group of people that put together their minds and published a set of common standards that make sense in the context of PHP. The idea behind it is that there's no framework. The code that I've shown you had 0 framework in it. There was no framework anywhere. And the idea is that we finally managed to kill the framework. And this is coming from a framework maintainer. Because we have way too much to say about your code from a framework perspective, and we shouldn't. You should instead take what you need from the framework and integrate only that, and not take the framework and adapt it to your application. So the framework starts becoming, again, the framework. It stays in the walls. You don't see it everywhere. We have a framework here for this building, somewhere inside the walls. You don't see it, because it's not important. We just want to know that the building will not collapse. Don't panic. So we are reducing the risk of having to rewrite every time we have an upgrade, and we're making it possible to write tools that you write once and can be used in a numerity of different contexts and libraries. So there's a couple interesting side effects to this. You're now pushing for immutability wherever you can. Not necessarily the best language for immutability, PHP that is, because of course you're trashing memory, but it makes things easier for developers. PSR 7 is immutable-ish. It's not really super immutable because of streams and PHP's weird version of streams. But you start seeing more of these value types being pushed around. So you have building blocks that are very clearly defined shapes, and you can squeeze them, you can throw them at a wall, they're not going to change their shape. They have a very well-defined shape, and it stays as is. So what you see more and more in applications is these framework-agnostic objects that have very minimal validation. This is a user ID object. My user ID, my concept of user ID is an object that has internally some integer, but that integer needs to respect some rules. And it is impossible for me to create this object without respecting those rules. So I can create it, pass it around, and I know that nobody tampered with it, unless you used reflection, and that's your problem then. Now you start having less kind of fundamental types from the language in your API signatures. How many times have you used the password verify and swapped the password and a hash? I've done it numerous times, by accident, of course. But what if you could define, look, one is a clear text password, the other one is a password hash. There's no confusion there, right? It's much easier to use too. I also don't need to really document that much, because the constructors of a password hash will tell me what a valid password hash will look like. So we started seeing more and more types leaking into that, and I saw that in the questions asked to Rasmus as well. We want more and more type system into this language. So we are kind of making our own. So there's Psalm, Fan, PHP Stan. Execute is more for generic analysis of a project and seeing if the project is holding up. And these tools are kind of creating a type system around us. It's a compile time type system. So we have limited guarantees. If somebody puts an eval somewhere in the middle of your code, you lost. There's nothing you can do there. But they give us things like maybe generics. You saw what I did there. Sorry for those that get the maybe jokes, but you start seeing more and more of a push of putting things out of the context of the runtime and taking decisions if else, if else, if else, if else, and more into the type declaration. So this type is only coyotes. It's a function that, given a request, gives me a response and can eventually also call something next. You make it explicit. You give it a name and a signature that makes sense for this continuation of execution. And you get more into this functional programming language, functional programming kind of approach. So, for example, what would you call a class that has a constructor and an invoke method? Well, what is a class that has only the invoke method? What is it? Sorry? It's a callback. It's a function, right? Once you have invoke, you have a function. What is a function that has a constructor that you already give some context to? It's a closure, yes. Anybody else? No? It's a carried function. Okay, so of course we're going into mathematical fields that I'm not, experienced enough to talk about that much, but the idea is that if you take your register user interaction, register user is a function that accepts user data, and that database object and that create user, which can be some sort of callback, are parameters that you give it up front. If you have this, then you can effectively call this a carried function. So I can take this, register user, and say, the database is a parameter, the create user is a parameter, and the user data is also a parameter. And if I put them together, it's one function called register user with the DB, with create user, and with the user data. It's the same exact thing. And what I can do is I can carry it. So I can say the constructed function is take register user and remove the database and create user parameters. Okay? So we are effectively doing functional programming. So if we take this and we start pushing functional programming further, we get away from things like ORMs as well. So we start seeing patterns like event sourcing. Event sourcing, I'm not going into much detail, but the idea is that you're not loading and saving one thing at a time and updating fields, but instead you're always pushing more and more information on what's happening. So event sourcing is defined as this. You have some action that you want to run, and you have a list of events in the past, and the command, and that will give you a new list of events. So you have some past, you want to do something, and there will be consequences. So you save the past plus the consequences, and that's your storage. So that is an interesting pattern because it goes very much in the direction of killing also ORMs and traditional relational storages. Now, it doesn't mean that this is an absolute solution, okay? But it's interesting that we're seeing this and seeing that it arises from all this evolution that we have around the patterns and the language itself. So you can now pipe everything, right? So I said you can build this pipeline and have one single configuration of your application and understand what the application is doing instead of having to open a file and read all the if and else's. And you can pipe through everything. So I'm going to have an application here that takes a request, produces a response, and does, well, some routing, right? For the route purchase, I'm just making pseudocode. This is not actual code, okay? I'm just taking an example of how this could be configured. It doesn't need to be JSON, it doesn't need to be PHP, it could be this weird thing, but you can also write it in PHP. So only when you have authentication, right? So we take the routing, whatever came from the routing, we pass it to the authentication layer. The authentication layer verifies that you have authentication. And if you have authentication, we're going to the only coyotes endpoint. And only coyotes will validate that you are a coyote before you can perform this interaction. And then you have to validate the form data. If the form data is valid, then we're going to create a command, which is now at the edge of what we would call the domain layer of our application, which is now up to you. It's no longer part of the framework. And you take that command and you pass it to an interaction. So you have to load some history and perform a purchase. So your command flows into this perform purchase. And now this perform purchase creates some new history about the state of your system, and you store that. And this new interaction, this new result from your system then can be serialized into an HTTP response that tells you what happened, what is the new state. So the point of this is that you now see that each of these interactions is kind of taking a decision and splitting left and right. Left and right. Do I want to go to an error? Do I want to go to a business interaction? Do I want to go an error? Do I want to stop the execution or continue? So each of these steps is what we previously would have as a helper that would kind of cut in the middle of the code and take a decision. So you see, there's no more service location. It's gone. We no longer do some runtime decision of how to fetch things if it's not about actually loading data that is part of the current interaction. And we don't have this idea of helpers. So we turned everything that is a cross-cutting concern, that is a decision that is kind of part of our logic, but not really like deciding if you're a coyote or not, is not really part of the core domain. What your core domain is doing purchases. Then somebody came and said only coyotes can do purchases. So you start having these cross-cutting concerns becoming function composition and piping. Piping is just one way of composing things there. And we got rid of most of the shared mutable state. We're just taking, well, just is a stupid word, right? But you are taking values, passing them to a function, that function produces a new value that you pass to the next function, and a new value that is passed to the next function. So if you put these patterns together and you start having more and more this push for immutability, functional patterns, functional composition, what you end up is good object-oriented programming. Now, I don't want to necessarily misquote Anthony, who's coming up next, I think, but good object-oriented programming is almost functional programming. You are effectively moving data from one object to the next one. No shared state. So, I think this is a good direction to go in. What is up next? I don't really know. There's a lot going on in type systems with PHP Stan, Psalm kind of doing a race of who has more features. There's a lot going on in the PHP internals. We start having type properties. We start seeing the push for immutability, people asking about it explicitly. We no longer want to do it manually in our own code, but we want to start kind of exploring ways of doing it in the language. And I think what is most important is that you figure out if you start pushing these things to the limit, not necessarily making business value, you're just experimenting there, but try to see what is important to you, what makes your applications better, and try to influence the community yourself because you are part of the community. Thank you very much. It makes an impression.
Hi, apologies, so I missed some questions for Rasmus. I'll try to reload now. There's just one at the moment, so maybe for a conversation over a beer, but don't you think ORMs have worked against things like event-driven and richer models, and maybe not the ORMs themselves, but the way people are using them? That's what people are.
So there have been two big movements in the ORM and in the framework world, which are using events as hooks. So anybody using Symfony 2, or Zen Framework 2, any of the two, right? A lot of people here. So if you look at them, you have this idea of events that you can hook into. And you can say, during routing, when routing happens, I'm going to change everything under the hood, and everything will look different after I hooked into this event and took a decision. It looked like a really good idea at the beginning, but then you end up with these impossible to debug stack traces where the framework somewhere during execution at some point that you don't really understand took a completely different route on what you wanted to do. And this applies also to ORMs. So you have data that you're saving and then some weird event listeners and some traps that we built because we said, oh, we want people to be flexible on this, that make the code very, very hard to reason about. Now, ORMs personally are kind of a problem and kind of a solution because what we want is to work with less squishy data and more well-formed data. So the idea, I think the concept that we all want is the mapping. We want to map a request to a domain object that makes sense for us and that is a translated intent of an interaction. We want to map a database record to an in-memory object that has a type that we can understand. So the mapping part of this is the core of the problem that we as PHP have, because PHP is a very squishy language. It's designed to, push things around quickly, or, well, designed. What Rasmus happened to build. And then we tried to make it better over time. So it's about having a well-shaped data structure, and then we build mistakes on top of it. Like in Doctrine, you have this unit of work, which is basically a memory leak by design. You're not supposed to necessarily use it for big data interactions, but people do that because they see a hammer and everything looks like a nail. But I think this mapping, this idea of mapping and having data that looks more like what we want is more important.
And the second one, this is about using the invoke magic method versus implementing some interface.
I like using the invoke method because using the invoke method gives you a good amount of flexibility with primitives that work with a callable definition. If you look at PHP Stan and Psalm, it is now possible to define functional interfaces in which you say, I want a callable that given a certain set of parameters gives me something back. You can now define that, and you don't really need an interface for it. It will be checked at parse compile time by these tools, so not really by the language. But the interfaces are not that important anymore. What is more important is that you have a very well-shaped type definition, sure. But the idea of having these callables and passing them around means that you can map, combine them, and do things like reduction operations that are really, really hard to do in object-oriented programming because you need to turn every object into a function again.
And that was it. Not sure if there's any extra question.
Any other question? No? Cool.
No? Okay, so for a break.
Thank you very
See you
much.
in half an hour. Thank you. Thank you, Marco.